In the last part of these videos, I managed to suspect malicious JavaScript file from this length to about half of its length by removing all of the if statements that encapsulated most of the code. By eliminating all of the unused variables, got it down to approximately 1/7 of the file size. Finally, in the end, after purging all of the unused variables and nonsense functions and empty try-cat areas, managed to reduce it down to this much code. I also managed to produce the coded strings that were encoded by obfuscating code. Let's start by eliminating more of that garbage code out of the way. I'm just going to take this back over to Notepad for visualizing this. Okay, function anu uses the function u and the function qjq. Now, is qjq used anywhere else? No. Is the function u used anywhere else? No. So what this means is we no longer need function anu, no longer need function, whatever the hell that thing was again, and we no longer need this u. That eliminates some more lines of code because we've decrypted all of their strings. We are now down to 80 lines. Pretty straightforward. Okay. Next thing I'm going to do here, just to kind of chop down some more lines, is place these directly and any places that they are required. So I'm going to the camera to when I'm all done. Okay, so I finished replacing all of the string assignments wherever they were used in here. And just for clarity, I broke this up big string according to where the comma breaks are. See what structure of each unit is. And now that I've replaced all the strings, I can go ahead and get rid of the declarations here. Function TC. JavaScript is case sensitive, so this is a completely different thing. Simply returns a random number between 0 and that. The place it's used is right here to determine EMV. And EMV appears to be, given the fact that we have DLL and EXE as two things to apply to the end, it looks like it is, going to be a file name. I'm just going to simply replace this whole function in line, just because it's only used in this one spot. I'm just going to replace it right. I can get rid of that variable and this function. We are getting a lot smaller. Okay, so let's just see how much smaller. Copy. Go back into here. Let's make a new. May mess up my big string. String cross. I just have extra spaces in here for visualization at the moment. Left over. Spaces wouldn't be there, but this will give an example for following through what's being produced. 56 lines. Okay, so let's see, what can we clean this thing up with? Function J, which returns an ActiveX object of the type being requested. Let's do this. Looks like I missed a string in one place. Any more Y functions? Nope. Okay, so what are we using? Y. Function K. No longer need it. Okay, so this is where I start to question myself and say, is function k something in the original code? Now, if anything uses k, we'll call it with a bracket, so that will simplify searching a little bit. Let's go back to the original raw file. At the beginning, function declaration, we have an mk, an ak, xk, no k being called used. So that is a dummy function that can go because it does nothing other than occupy space, leaving us with only function f taking up slightly bigger than one page. Okay, let's do a little more cleanup, and for this I'm going to do this in Notepad just for, I don't know what, for simplicity, giggles. I like the fact that I can highlight like that immediately and see the other results. That's why I'm using Notepad for this right now. Okay, I'm just going to quickly take a look here, see if we can reduce a little bit of stuff. I see a switch E. There's a big capital E and a lowercase e. And that capital E tells me that probably missed something. Probably, actually, that's probably one of those string constants that I thought I copied and didn't. Okay, so let's go back. Oh, big E is right. Okay, so that was just a copy-paste error at one point. Maybe I already fixed that. Might have hit an undo by accident somewhere along the line. Everything in function f here, these are the only uses of E, which is kind of good here, because let's just give this a new name for right now. This is going to be something split up. We first take this big long string and we split it out by commas into individual units. So AI7 is going to be a unit web data pack. Okay, so now for E, we look at the 0, 1, 2. That's 1, 1, 1, and 1, and 1. It's always 1. So this is always going to be the value of 1, which means this is now a constant. So, well, does E ever get changed? No, it doesn't. So, is 1 equal to 1? Or is 1 equal to 0? It is not. So, we don't use this. We just use the other line. What about the switch? Is it ever going to be case 0? No. Only going to be case 1. And that break was to get out of the case. So there's our new code. Now this kxn becomes a constant, plus dot plus exe, so that's what this will become. We don't need that. Now everything fits on one page from 1544 lines? Yeah, 1544 I think it was. Okay, so time to start assigning some things to these variables as well and start making sense of these. Oh, here's another thing. Did I miss this? No. Okay, what is be the second element of the group? 1, 2, 3, 4, 5, 6, 7. It's just a consecutive thing. So we'll just call this a index. We didn't need that E1. Okay. Let's see here. Well, this is simply a counter variable, and it's only used just to divide that web data unit here. Okay, that's all of those. Well, TC is just our encoded web string data blob. Lack of a better term. Okay. EUF. Well, that is our target URL. Okay, next up. Let's find these things. EBS, Windows Script Shell ActiveX object. So this becomes a system shell object. But CZ is file system object. Okay, and KS, MXL HTTP. That, before, is Internet Connection Request or Transfer Request. Actually, it's a request object, but leave it the way it is right at the moment. Okay, starting to get there. What about this guy? I saw this one the other day too. The ADODB stream is a data streaming object, or data streamer. That can stream either binary or text data. Alright, what about XY? Let's look at RO. File system object get shell folder. Well, I'm betting that the Windows file system object has a method. I'm just going to open up Google here. Get here. Surprisingly, there's a get special folder method. Object get special folder, folder fact2 returns temporary folder. This will be temp folder pathway. What does that make this then? Well, we have a temp folder path, we have a random number, an exe. So this becomes randomly named exe file name. That is the transfer request response body. So this is the response body data. And what about W? Well, whatever this is, okay, so we get a response text value back. That's a string. We take first two characters, that string. So this becomes first two characters. Okay, so LZ. It's interesting, it's actually never assigned until at the very end. So this is some sort of flagged value for this index. Over here the value is, if it's equal to 1, we continue, meaning do the next entry in the for list. Whereas down here, we are setting the value to 1. Well, clearly this is a kind of thing saying we already did this one. Okay, so all of the code has been changed, I think, except for here. DN is missing. Okay, it's going to take a second to go look in the original main code and see where DN was found. Not part. That was the case statement. Case statement that we got rid of. In other words, we don't need that anymore. Now we should be able to make sense of the script going from the beginning. So we take a list of these things, we break them down, and for every single one of these entries, we break up this unit, get the target URL, and obviously an index number. We check to see if we've already done it, which of course we haven't at this point in time. Make a system shell object, make a file system object, make an internet request object, open a connection to target URL. I think the false is something to do with asynchronous or synchronous connections. Internet transfer request, we send that request in, and then we wait. It's going to be waiting for the page response. Okay, so if the response value is 200, then it will go ahead and do this stuff. Otherwise, it will continue doing the next entry in the for list. Status response could be 404, page not found, or 30 something redirected the page. If that's the case, ignore it because it's no longer the target we want. Otherwise, that means we do have the target we want. So what it will then do is take that result and open a data stream and read that response back from the data stream. I have no idea how I remember this. first two characters MZ are magic bytes for a Windows executable file. Doesn't matter what you name the file, you can always tell by those first two bytes that they're going to be an executable file. So what this is looking for is saying, well, did we get a response back? Did we get a result? And if we got a result, are we streaming executable data, or are we streaming the result that we expected that's going to be our executable data? It could have been cleaned up or it could have been replaced. So it's only going to do this if the data stream contains that executable byte stream, which will then write out to the data streamer object. And we look up the folder here, make a random file name, save it with this random file name, close it, and then immediately want to run it. Now this is actually the look the system shell up. That'll be something like this is a hidden window. So this script, after all of that 1,500 and something lines of obfuscation, is a very common procedure of basically requesting a malicious file from another site using active exploits within Windows. Now the question would be, any of these sites have that page? Since simply loading up that page won't have any effect, is only here, this is the whole, write the code. Should go and take a look at these sites. Oh, here's an issue. We have spaces in the middle of, I don't know if that was something that came as a result of a replace, or maybe when it thought this was a comment, that could have been it. Okay, we got a live one. We probably hit an error or something. Still, means the file is there. I was expecting to have to go through all of them and find that maybe none were. Again, I'm not worried about it. Interesting. And that is why it tests for the W&M. Somebody found it and messed with it. Locky. Locky is a familiar name. Why is this? Well, ransomware. Ransomware. So, ransomware, nice and nasty. Ransomware is that material that encrypts all the files on your hard drive and demands that you pay them a ransom. And this actually did do an awful lot of damage when it came out originally. Still, it'd be interesting to find one of those, but I now know what it is. Somebody identified that was definitely Locky because they made fun of it by replacing the file for it to be downloaded. After I realized that the pages were just throwing errors, I decided to check every single one of them in a browser and found most of them were pages that just came up totally blank. Some of them just could not load a page whatsoever or even load the site. Many of them had 404 pages, meaning they've been removed. Some had security things already in store that didn't allow direct access to the file. Some sites just completely, again, like I said, just blanks. This one was interesting. The entire site was hacked, not just simply the file. Every single page on that site redirects to this message. So clearly that site was very hackable, very vulnerable to multiple attacks of different people. Different accounts suspended, probably because of the hosting of the malware and being identified as a big participant in a serious threat. And yeah, one that actually has an actual file size, which I have saved and I'm going to rename that later to protect myself from it. But one of these days, I'm going to actually try to do a binary deobfuscation to find out, or to take a look at what's going on inside of it. But right now, that is a deadly virus for me to actually have on my computer without isolating it in another special way.